Yep.
Oh, gotcha. Hello,
Cool.
Giark.
Hello,
How are you doing
Giark.
today?
Oh my god.
What? I'm just saying hi.
Ethan, adding an X behind poop. What? I didn't type that. He's slandering me.
Yeah, I don't. It's possible. It's very possible that I actually did type that when I was very tired.
You didn't. Ethan
I did not? Okay, very cool. But I was the one who typed what? I didn't type that. Who's slandering me? That was me.
He's only taking partial credit.
Only I'm taking 80 to 85% credit.
So I already kind of told Try this, but I've learned that I regret turning on my camera during lectures for Zoom, and 2, hate the private messaging function on Zoom for my lectures.
There's a private message, so like the students can like talk with the teacher or like among each other.
Yeah, like talk with the teacher or among each other. Like me and my friend have used it when we're like chatting about the homework or something, but we don't want to let everyone know. But today, someone in my differential equations class thought it would be appropriate to use that function, and I'll just read you what he said.
Oh boy.
He said, "Normally, I would have just sat next to you, but I guess this is the best I can do. So add my snap if you want. By the way, I'm on my friend's computer. My name is John."
Oh no.
I was like, if you're down to just hang out or study, that's fine. I'm dating someone if that's what you were implying. And a long moment later, after turning off his camera, long pause after turning his camera off several times, he comes back and he goes, "Yeah, we can hang whenever, especially if you bring your friends." And I was like, what friends?
Heck W.
I should hang out with him and bring all my friends, because all my friends but one are dudes. And I'm sure that's what he was looking for.
Yeah, that sounds like his goal, I'll be honest.
Okay. Yeah, so I now am very uncomfortable by that function.
What was the camera thing? Is there a story there?
Like why the camera was on?
I don't know. I thought you mentioned that as being the one of 2 sections to your story.
Well, yeah, because this person could see my face.
Ew.
Instead of like just my name.
Right. I see.
I mean, it would have been really ballsy if everyone who has a vaguely female name in the entire group, in the entire like 200-person class, is just like, by the way, here's my snap.
I briefly thought that was the case. It might have been the case. I don't know, because he was privately messaging. And I was like, sir, I am trying to educate other people in the chat about the questions that they have, because my professor's not particularly good at looking at questions in the chat. But I understand what's going on, and you are making this difficult.
Dude, he wouldn't be a good streamer. He doesn't even talk to chat. What a loser.
What a loser. Today we learned about stable and unstable functions.
Love that. Classic.
Let me know when you're done. Try.
I can keep going while if you guys want to start talking.
Oh. Okay, well, sure, I guess.
Yeah, let's just fucking send it, is sort of where I'm at. I don't want to hold up anybody any longer than I already have.
I mean, I feel like I'm the one that's hold up people the most.
So, the first quote. Poop.
Poop.
What do we think? Looks like 2 people X that.
Yeah, so the inspiration for this piece of art that I've added to the doc here,
right,
was that Ace told me to type anything in the document just to verify that it was editable.
Be right back. Continue.
And I decided that this might be the single most salient thing that I could say this week.
Wait. And you used my color?
Well, see, this is sort of part of the interesting thing here, where she told me to type, and I wanted to make it clear that I didn't want to take full credit for my art. I wasn't proud of it.
Right. Okay.
And
so everyone involved understood that it wasn't you,
except
even though it made me feel more comfortable expressing myself.
Oh, okay.
Well, you said that everybody knew that it wasn't me, but I did not know.
Wow, I mean, I wasn't aware anyone was going to interpret it like that. That's deep. I did a better job than I realized.
You did too good of a job. This is true.
Mm-hmm.
Okay.
I made Rainbow unsure of himself.
Let's continue.
Sorry.
Right.
It's all right. So the first X thing we have here is in chapter 6 on page 96. Oh, also, hello. Yes, you're being recorded. You know this. I'm Space Lord Ace.
Oh, I'm Rainbow Trout 950.
I'm Try Too Hard for You.
And this week we went through chapters 6 through 8 in Alien Oceans by Kevin Hand. Did I get that right? Yeah, Kevin Hand.
Mm-hmm.
I don't have the cover of the book on because I ruin covers of books if I read with them on.
Kevin Peter Hand.
Kevin Peter Hand. There we go. That's right. He does include his middle name.
Mm-hmm.
Anywho, the quote says, Enceladus is only 504 kilometers in diameter, which is about the distance from Chicago to Cleveland or from Johannesburg to Durban. And I was just thinking about this, and if the entire moon is only 504 kilometers in diameter, like, surely that must impact possible life, right? Because we know overcrowding is a thing, and like overuse of resource will cause evolution to steer a different way.
Or like just minimizing space reduces your ability to have like a large population for genetic diversity.
Yeah, and I would also imagine it reduces the chances of life actually happening. Like I feel like the more square footage you have of habitable space, the more likely it is to happen, perhaps. I don't know if that's true.
I mean, I feel like that falls under sort of almost more of a chemistry question where like if we're hoping that amino acids and whatnot are creating themselves through like effectively just chemistry, there's a thing called collision theory that is the guiding principle of chemistry, which basically says the reaction will only, or basically the chance of a reaction occurring is related to the amount of reactants and the temperature of the like medium. So basically, if the two molecules that you're expecting to react can't run into each other, the reaction can't start. So for example,
right,
like if you add the same ingredients that aren't warm, like if you freeze them and then add them together, the reaction is less likely to happen because the molecules aren't bumping into each other. And I would imagine this is the sort of the same concept here with the less of the reactants, the less likelihood you have of the reaction occurring.
That's true.
I guess like that's more of a idea of like density than like pure surface area.
Yes and no. I mean,
like ideally, if it's of a certain composition that indicates a certain density, and the idea would be carrying that same density over a larger area, if that makes sense. So uniform density, just more material. So I guess that would impact it, and so does time, which I think he mentions later. Was a quote that I put somewhere.
Yeah, and increasing density doesn't necessarily increase the chance of a reaction occurring just because the denser something is, the less likely it is to bump into something else.
Yeah.
Wait, I thought like the denser it is, the more likely it is to start bumping into each other, like in like a bunch of people in a mall.
So that's true to a point. But imagine you have a mall that has 20 people in it. It's not very likely for people to run into each other. Now imagine it has 1,000 people in it. They're more likely to run into each other. Now let's imagine you try and pack so many people into the mall that they all turn into just like a gridlock and none of them can move. You're much less likely to run into your friend or the other person you're looking for because no one can move anymore.
Okay, yeah.
Interesting.
Or the reaction is going to take longer because you're moving, but you're moving so slowly through a sea that is that dense.
Okay, that makes sense.
Gotcha.
Yeah. But the kind of point that I'm trying to make is that you need like some density for things to be likely to happen.
Absolutely, absolutely.
So like if you have like an absolutely gigantic ocean, like bigger than the sun somehow, I don't know if that's possible.
No, I got you.
Like I don't know if you would be able to have life on there because the resources might be spread thin.
Or like you could have life, but it might just be like microbes, you know, like you might not develop anything what we might consider intelligent, perhaps.
Mm-hmm.
But yeah.
I think something else to think about is, like, for example, at a lot of different points in light, in like the history of the Earth, there's been these sort of booms in one particular evolutionary track or another, where you end up with just so many plants or so many small invertebrates that they completely wipe out everything, and they become super powerful in the basically the entire global ecosystem. I'd be curious if that would happen more frequently because there's less to take over, and that might also impact your ability to have new novel creatures be successful, especially with what at least sounds like it would be a relatively homogeneous ecosystem.
I also wonder if like intelligent life could exist, but we're just used to one size, like almost how there was more oxygen before the meteor impact that killed all the dinosaurs. Everything was larger. Like you had things like megalodon, like lizards were bigger, insects were larger. So I wonder if having a smaller space for life to exist, if like perhaps you just find smaller intelligent life and their scale of living is so much smaller than ours. They just simply scale down to match the surface they're on, similar to if there was a really large planet, like several times the size of Earth, it was just as habitable. Perhaps we might be adapted to be larger or fill up more of that space. Like I wonder if that's something that happens as life develops elsewhere, if it scales to the size of the place it is living.
I mean, I would imagine that is pretty dependent on like, I think it can only be smaller to a point, because I think there's a lot of really important checkpoints in intelligence that like would require you to be of a certain size.
But
like,
I mean, mice are pretty intelligent.
Right, but I don't think they're ever going to be human smart, because like part of the thing that I think made and this is now much more conjecture than it is anything solid, I feel like humans wouldn't have ever gotten to the point that we're at today if we weren't big enough to use tools. And like, sure, you could say just have smaller tools, but like those smaller tools are going to be immensely more fragile and less able to like make an impact on the world around you, so there's going to be less incentive to even use them.
Interesting thought.
I don't know if that's something you guys would agree with, but I feel like there's definitely almost a diminishing returns on using tools, for example.
Yeah, it does
But
make
that's
sense.
also contingent on using tools in the space that you understand. Like it could be that, like, say there's another type of wood or something, that it grows smaller. It is smaller, but just as dense, like a tiny tree, like a bonsai tree or something, right? But that's all they have. Then they might also scale to be smaller, because then you get to a point that you're so big, things like eating a couple of berries isn't going to satisfy you, and having brush everywhere isn't going to make a shelter, so then you might get smaller. So like I feel like the argument you're using for things being big enough could also work in the reverse, like things being too big.
I guess I'm just more concerned, like, shelter is the kind of thing that everybody's looking for, whereas like tool use, I think, genuinely only works at some sizes and like is important for intelligence, whereas like shelter is just important for living, which is why mice are small.
But like you use tools to build shelter at some point, right? Like cut down a tree.
Sure, maybe, yeah.
But if there were no tall trees, like all the trees were small, or like
you didn't really have the resources to do anything with tools.
Or perhaps on our scale the rock's too brittle, but on a smaller scale the rock is sharper, denser, more usable, because the force isn't being spread out over such a size of it.
Yeah, that's fair. I mean, I guess
I'm just playing devil's advocate here.
No, for sure. I'm just trying to think of like because I feel really strongly about this point, and I'm just like, I feel like I can't explain why tools don't seem as useful at a smaller size, and that might just be because I don't really have a good reason, but
I mean, a good reason is it's what you've experienced, therefore it works. And it might be just hard imagining it works. Because, I mean, fish use tools, really tiny tools, right? Like there's the fish in the Great Barrier Reef that use, they pick up the pebbles, right? Or they pick up the shells or something and they throw it to break it open.
Oh, wow.
Have you heard of this?
Yeah, sure.
Yeah.
But
That's
I would
like
also...
tiny.
Yeah, that's fair. And like, there are birds that, use a small twig to pull grubs out of a tree, right? Like, that's a thing that happens.
And hummingbirds use spider silk to, like, make their nest strong.
Mm-hmm. And that's fair. But I think somehow, in my mind, those applications of tools to the step of, generally applying using tools for everything, like, I think that's a really big step that we've made as, like, a species.
Mm-hmm.
And I'm not sure that you'd have the same you wouldn't be on the same, like, intellectual pathway if you weren't like, I am using this tool to change the environment around me, and it is a general purpose tool, versus like, I know I use sticks to pull bugs out of a log, and now I don't think about that stick when I'm not trying to pull a bug out of a log.
I have perhaps the greatest counter argument for you ever of mankind. Tinkerbell. Or just like Sans joking. Like, people build things like fairy houses, right?
Yeah.
And they're actually functioning. Like, there's some people who spend the time to make something so tiny and so small that they're actually functioning. And they use small tools that are of similar size because they're making something so small. And I feel like if we have the ability, perhaps, to make something that small, there is at least something down to the scale of mice that, if we were developed to the size of mice, I still think we would find a way to use tools, and it might not be the tools that you're thinking of, because you're thinking of the tools that you exist with now.
Mm-hmm.
But I would say that's another prime example of, like, the ability to scale down tool use.
Yeah.
Maybe. But fairies are also not real, so I don't know. But also, we're all talking in hypotheticals, so fairies.
I mean, I also think like that those are small tools being used by full-size people who can apply full-size force to them. Like, would those tools be as useful if your arm, instead of being 18 inches or like whatever it is, 3 feet long, if it was only 16 inches long?
Perhaps.
Like,
depending on how you're built, like, you just wouldn't be a human, like,
right. But I mean,
kind of human, but
yeah, I mean, I'm just using the tiny human example because, like, like, the lever is shorter, and unless they've figured out some way to, build a body that isn't, like, is so foreign to us that, like, they're not using, they have ways to multiply force that we haven't seen evolve on Earth.
Yeah, I mean, ants are, like, a good example, but
yeah,
they wouldn't need those tools because they have bodily tools that do similar work for them.
Yeah, I don't know. And we can move on from the tool idea. Yeah.
Moving on. The next thing of interest is Rainbow's quote on page 97. Mother Nature did not set up something akin to airport security in the Saturnian system.
I really like the word Saturnian.
I like that word too.
I don't know why, but it stuck out to me as like, ooh, that's a good word.
It's like similar to the word Saturn. I like it.
Well, yes. So what made you write down this quote, Rainbow?
Well, yeah, on the page, I omitted part of it. It just sounded funny. If you say, like, Mother Nature did not set up airport security in the Saturnian system.
Yeah, I thought it was pretty funny too. I like that he keeps carrying these metaphors or analogies throughout. He's like, well, we did have this thing, but this thing doesn't work here because this thing doesn't exist over there. But instead of saying that, he's just like, nah, they don't have airport security. I'm just like, nice. All right. The next.
I noticed that there didn't seem to be as many metaphors this time around.
Yeah, it was very science heavy.
Yeah, it wasn't wasn't messing about.
The next thing would be your next quote, Rainbow.
Yes, it's me.
To put that distance in perspective, on page 98, imagine throwing a baseball from Los Angeles to New York City, having it come within 6 inches of the home plate in the Yankee Stadium. Like, that hurts. Like, I don't know. I just think it's so fucking insane what, like, we do with science sometimes when it's that far out.
So I feel like I didn't quite understand this analogy, because wasn't the orbiter already at Saturn when they decided to make like a minor course adjustment to make it fly closer?
It was already at Saturn, but I don't think it's as minor of a course adjustment as you're perhaps anticipating. Because the biggest thing here about getting it within 6 inches of home plate is not about like actually hitting home plate. It's about the precision, because they have to get close enough to this. Because remember, Enceladus is Saturn's massive.
Yep.
Saturn is several times the size of Earth, but Enceladus is only 504 kilometers in diameter.
Sorry, maybe my question wasn't clear. Is that LA to New York, Earth to Saturn, or like Earth to the moon there, or is this just on the scale of Saturn, where they were planning to be was nowhere near Enceladus?
I am very convinced that it is Earth to Enceladus, or whichever moon they're going to, and coming that close to Enceladus.
It's not Earth to Enceladus. It's where they were when they decided to do this, orbiting Saturn.
Okay.
To Enceladus. And I guess the point I was trying to make is scale here. So, yeah, I guess that is where the scale is.
Yeah.
And you have a very expensive piece of equipment.
Mm-hmm.
And you're getting it very, very, very near a surface, just so fucking ready to destroy it. But also get it too far away and you've just burned a lot of fuel and energy trying to get a recording that you couldn't get because you were too far away from it. Which I just think is rather remarkable. Yeah. Like, it's just math, but still, like, beyond math, you just had to pray that the thing actually did what you fucking told it to do at the time that you fucking told it to do it. And that's nerve-wracking. Fuck that. Also, self-plug here, Dr. Nathan Strange, Avenger himself, is apparently in this book, so that's cool.
Gross.
Let's see. Here's another one of his analogies. I don't know that we really, I don't think we've marked anything about it. Just the coin. Yeah, the coin sorter.
Mm-hmm.
Yeah, it's the cosmic. Actually, I don't know which one it is. It's either the ion neutral mass spectrometer or the cosmic dust analyzer.
Yeah, those. I really liked that analogy.
Yeah, they're talking about the mass spectrometer, the INMS.
Mm-hmm.
Correct. Well, they're both mass spectrometers. It's just in general how a mass spectrometer works.
Yeah.
And I think mass spectrometers are so fucking neat. I think, if I'm remembering correctly from one of my classes, mass spectrometers can work using magnets, like induced electric fields. And they can actually make it such that only a particular particle can fly all the way through it, and any other particles would get pulled off by this generated magnetic field and hit the side and never make it through.
Oh wow.
And I'm not sure. It sounds like it's the same thing. But yeah, I don't know. It's just crazy. Whoever thought of that, once again, just kudos to scientists and engineers. They can be really smart sometimes, and that's pretty neat.
Do be really smart sometimes.
Yeah, all the other times they're dumb. Just kidding.
Honestly,
I mean, to be fair though, most of us are dumb most of the time. Like, I don't even know what a kiwi is. I don't eat sushi.
It has hair on it.
Rainbow.
Yeah.
Do you eat the skin on a kiwi?
I have not eaten a kiwi, so no.
Oh. Okay. Well, Never mind. Apparently, I'm
Although
weird.
my answer would probably be no.
Your answer is no. You don't eat the fuzzy skin. That would be weird.
Fuck off.
Wait, like, are you saying that, like, I don't know, do you, like, cut the hair off?
It's pretty glitchy. Welcome back, Georg. You missed
I mean-
nothing, people listening.
Yeah, I mean, in the, I don't know, like, 5 or so hours that we've recorded, it's only failed, like, maybe 3 times, I think.
On the other hand, though, I feel like people who use Geark are probably not using it to record like long term.
That's fair.
Yeah, I
Like-
think it said the average recording was, like, an hour or something.
Okay, let's see what the next thing is here. I believe it is. It is. This is StealthSoft, who is not here currently. Quote on page 100. I'm trying to see if I can. Normally, when you guys write something down, I had it highlighted. Oh, here it is. Could this water be coming from an ocean below ice? Could this ocean be rich with carbon compounds that are useful for or even made by life?
Mhm.
He says, had me wondering if the pressures were high enough to send a particulate kilometers into space above Enceladus, and there's microbial life around the thermal vents, someone would almost surely be dragged along and expelled. And if the right equipment was present, we could capture it, or likely its remains if it was there. The INMS was not equipped for that, obviously.
Yeah.
Yeah, not equipped to detect organic life.
Yeah, I think he poses something interesting here that perhaps I hadn't personally thought about, which was detecting life directly
Mhm.
without landing.
Yeah. Like you would think, oh, that would require a space whale to be flying around the planet, but like totally possible in that sort of event.
Yeah, I'm just curious if we could get a good enough mass spectrometer there that wouldn't destroy it. Like beyond recognition.
Yeah, I mean, I think we could pretty easily take like a water sample and right, a sample of that mist that's being ejected, and like that seems like totally reasonable to me. Although, would
No,
it
not
be destroyed?
taking the sample of the mist, but
Mm.
destroying the actual microbe itself. Whatever may be living in that, destroying it down into compounds that we'd be like, oh, this came from organic life, but not this was organic life. And
Yeah.
Yeah.
fucking, well, it was already gonna die, but we just fucking obliterated it. It was like a poor bug on a windshield.
Yeah.
Like you see something sticking, you go, yes, this was most likely a bug. But most people cannot identify
What bug it
what
was.
bug, when the bug hit, how long the bug's been dead for, like all of those.
How much of the bug is actually there.
Yeah, like I totally think we could fly and catch it and hopefully recognize that this was not just a byproduct of a living thing, but this was something living. Regardless,
very
that's
cool.
proof of life, but it would be better if you had something recently alive and somehow you could tell because that's evidence for like life immediately there, that very moment.
Mhm.
I'd be interested to talk to some people I know to see what they think the possibility of that is.
You just gotta catch it like you're playing egg toss, man. Just gotta sync with it.
I don't think that's how it works.
I mean, in principle, that's how it works.
In principle, that's fair.
Gotta catch it really gently.
Well,
Yeah,
I
the
think that's not how
engineer
mass
breaks.
spectrometers work. I think they work. They work with speed. They need speed.
Don't they like have like a net like filled with like toilet paper so
I
that
know
it
a
kind of
net.
like softens it?
Sure.
Yeah.
Yeah. Totally. No.
I should send some blueprints over to NASA.
All right. Moving on.
I
So
wonder
we
how
said
often NASA gets mail that's just like, I have an idea.
I haven't probably all the fucking time. But that's what they do citizen science stuff for. Usually they have like forms that you can submit it. All right. Moving on. This was my quote on page 101. The E-ring has long been known to exist very close to the orbit of Enceladus, and thus when Cassini found plumes on Enceladus, it was not too surprising to see that the E-ring was sourced by the plumes. I just thought that was fucking mind-blowing. Like, I knew rings came from, like, collision events and, like, dust flying through that might have just gotten caught up. but I had never considered like an active source for a ring, if that makes
Yeah.
sense. Like something
Like,
constantly fueling a ring, like an atmosphere, had not considered. Mind blown. That's all I had to say about that.
I mean, it's basically like a contrail from a moon.
Yeah, it's crazy. I wonder though,
Wait,
like,
moons have contrails?
I wonder if the
I thought it was
E-ring
like
is
comets.
actually visible. Because I know there's rings that we can't really see from Earth.
Mhm.
So I wonder if the E-ring is even visible, if it's kind of like a gaseous ring, which it kind of sounds like it might be here.
Mhm.
But still, wow, neat, like that. The next one on page 104
Yep.
is they grew microbes under similar temperature, pressure, and chemical conditions expected in Enceladus' ocean. And then it continues, the proof of the concept exists. That's so fucking cool. Just once again, just like really cool. How have I not heard about this? I
Yeah.
do not.
I feel like that's the kind of thing that should be like front page news.
Yeah, like we took conditions on from a moon orbiting another planet like light minutes away, and something could survive that we know of and like actively existed in that environment. But when did I hear about this? That's so fucking cool. Like that's the most convincing thing I've heard. Like I'm already convinced life exists, but I think that's the most convincing thing I've heard, that other life exists in our solar system.
Yeah, it's interesting because I feel like there was, as a child, I had like this really steep increase in like, oh yeah, life exists and it's probably right around the corner. Aliens are here. And then like as I got older, I stopped thinking that like the aliens were controlling us all, and like, oh, maybe aliens aren't actually a thing locally.
Nice.
Yeah.
But this is definitely like very, very convincing that no, if they exist in conditions that we are aware of in anywhere in the galaxy, they also definitely exist in conditions we're aware of here
Yeah.
in our home solar system.
It's crazy. Also, there's something here that I didn't write on here, and I just, if anyone knows of the stream Excalibur 009 and our jokes about cavitation, I really like the word liberating to describe it wobbling. Liberation. It's a great word.
Yeah. I
And I'm
don't
going to
really
start using
understand
it.
like exactly how the word like works. Like I think like Libra, I think like free.
I got you. Libration is an apparent or real oscillation of the moon by which parts near the edge of the disk are often not visible from Earth or sometimes come into view.
Yeah, that's like just optical, isn't it? For the moon.
No, not all the time. There is optical libration and there's physical libration. They went over both.
Yeah,
In
but
lunar
I thought,
astronomy, huh?
yeah, I thought they said that the moon was like all optical because it's kind of something something, but like with these other moons, it was actually happening.
Not totally. So they say there's a slight mismatch and an apparent wobble or optical libration of the moon, but then they continue and say how there are, however, actual physical librations or real wobbles that occur as moons with their orbits. Such as our moon, it's not a perfect sphere, and gravity tries to realign the mass of the moon with its planet. Therefore,
Gotcha.
our moon is a little oblate and has a fixed tidal bulge, which also causes it to, like, wiggle, if that makes sense.
Yeah.
And here it says libration is the wagging or wavering of the moon perceived by earthbound observers. And this is something I'm definitely going to drop in X's chat. Liberation. Stop making me liberate. Like, yeah, it's going to be good. I'm excited. That's all.
Gross.
Exactly. Do we have any more? Oh, we do. We have one more. On page 107, on the other hand, tens of millions of years could be plenty of time. We just don't know.
Yeah.
The bit before that actually says an ocean has been around for billions of years, may have a better chance of harboring life. than one that's only been around for tens of million years, on the other hand, yada, yada, yada. Yeah, just like, I'm frequently surprised when learning about science how little we actually know.
Mhm.
Like, whether it comes from my upper division classes or learning stuff about Mars, like, there's so many things, for some reason, I just assumed we knew.
I mean, I think that's something that comes from like the education system where pretty much any question you ask for the first 18 years of your life, somebody has an answer to.
Yeah.
Like maybe your teacher doesn't, but they can be like, "Oh yeah, you can Google that," or "Oh, you should look into it and you'll find an answer." And then you enter the real world and the answer is like, "No, most of the time we don't know." And like I feel like that's especially true with something like abiogenesis, which is like such a mysterious process.
Yeah.
It's like not something that's ever been able to be recreated in a lab, and like that's interesting to me.
Isn't biogenesis that thing where like you say a fly appears next to steak?
No.
No.
Abiogenesis is basically at the point at which chemistry becomes biology. Like how do you go from chemical soup into a living thing? Like how does that process work? What does that actually look like in reality?
Yeah, doesn't it require some like weird source of energy to kind of like spark things up?
I mean, we don't know. There is
Okay.
no known case of abiogenesis ever occurring in like a verifiable way.
I'm probably just spitting out like theories of how it might occur then.
Oh yeah, no, there's definitely been like, oh well, maybe you've got to have a pool full of amino acids and you hit it with some lightning.
Yeah.
I feel like that's often how.
Frankenstein shit.
Yeah, I feel like that's for some reason I have this lightning strike idea in my mind, as well, and I'm not sure where it's from, but I've definitely been like, oh yeah, they hit it with some lightning and then there was life.
I
And
think
I think
That's what I've heard as well.
I
But
think
oh, go ahead.
I was just gonna say, I think that's something that comes up in like high school biology. Like they briefly talk about it, but we're all just like so fixated on the idea of Frankenstein and shit like that we were just like, lightning makes life? What?
Yeah, and
I hesitated to say that a second ago because it sounds so weird now. Like, oh yeah, just hit it with lightning and it
no,
sparks and it comes to
for
life.
some reason that is what's stuck in my mind about like, oh yeah, that's how they show it happening. But I think the answer is really just a lightning is an interesting enough thing, like a lightning strike, that it is our stand-in for like fucking magic happens and then there's life.
I think it's also just like one of the few ways that we can explain on our Earth a lot of energy, like a lot of energy being naturally generated.
Yeah,
Mhm.
kind of like
And
a
I
Back to
feel
the
like
Future.
we're just like, oh, we haven't seen it in a lab because we don't have the ability to put enough energy into it. And they're like, well, what does? You know what? Lightning. That's a lot of energy. It literally
him.
turns sand into glass in seconds.
Mhm.
Uh,
Less than a second, not even seconds.
Sorry, that's right. Sorry, milliseconds.
I was gonna say, if your lightning strike is lasting multiple seconds, that's fucked.
Get scared.
You're gonna hose that glass.
Yeah. So cool though. Love that. Next on to chapter 7, page 110. Cryovolcanism. I just fucking love the idea of cryovolcanism, but I'm curious how you guys think this would look and how it would work. Because clearly it's not going to be magma. That kind of defeats his purpose for explaining cryovolcanism. It sounds like it's perhaps buildups of like warmer gas, not necessarily like magma. Right?
Yeah, I mean, I didn't really get it, if that makes sense. Like, cryovolcanism. Sure, it's the
That's like
concept
ice
of like,
and volcano.
yeah, that's like volcanoes, but not hot. Was the takeaway I got, and like,
Well, also the entire surface is made of water ice.
right.
So the actual volcano itself would have to be made of entirely ice, which is just my brain. No, like what is this? Is it fucking Shark Boy and Lava Girl, the Crystal Mountain? Like,
is it like shooting out superheated water?
I don't know. It's just like volcanism is a known way. It's a known component of the cycle of gases. So gases eventually fall into rocks or bottoms of oceans and whatnot, and eventually get trapped in magma and rock and sediment. And one of the ways for that gas to be released, sans like nuking an ice cap, is volcanism.
Yeah.
Which is how we know that Mars was definitely, like, other than other things, like ways that we know Mars had an atmosphere. It's got one of the biggest volcanoes in our solar system that at some point must have been active and was expelling a lot of gas. It's also the same reason that ideas like Yellowstone erupting are so terrifying, is because it's releasing so much gas and clouds and shit into the atmosphere that it would block out the sun and freeze everything.
Yeah.
So I don't necessarily know exactly what would be coming out of it. Like, I'm assuming it would be somehow gas from the lower layer of the planet, like, escaping to fuel it. Or perhaps it's like, does a volcano have to be magma? I don't know. I'm confused. Like, does it have to be magma? Could it be like a volcano just erupting with gases from the ocean? Or is that not just a geyser? Like, I'm confused.
I was also curious, maybe this is not, maybe the key difference isn't like volcanism in the sense of like, it isn't magma. Maybe it's just, or like maybe the difference isn't like what is coming out, it's just that it's not because it's hot, it's coming out because it's pressure. Like, you have gases and vapors and probably fluids that are being ejected from like the inner layer of the planet, and it's coming back up not because it's hot, just because there's a lot of fucking pressure down there.
Yeah. Okay, here, I found something if you guys are looking.
Yeah, I looked it up as well. Says that it's usually like liquids.
Yeah. And some, they call it cryomagma.
Cryomagma.
And also it mentions that either the tidal friction or the subsurface greenhouse effect that's mentioned in chapter 8, that could be the energy for the cryovolcanoes.
I just feel better here that it also lists it as a cold geyser. So I was kind of right. It is also funny. In just a way a geyser.
Yeah.
That makes me feel better. Now, because I already know what the next thing is, I'm gonna start seeing if I can pull it up quickly. Which is yeah. So an Intrepid, it's on the bottom of page 110. An Intrepid hiker did, however, pierce the atmosphere and touch the surface of Titan, providing some clues to geological activity along the way. The Cassini spacecraft carried with it the Huygens probe, built by the European Space Agency. And I've seen an amazing video in one of my classes of the Huygens probe landing.
Yeah, not to kind of put down this whole thing, but the whole metaphor calling it an intrepid traveler or hitchhiker.
Oh, I found it.
It made me imagine like a literal human like parachuting from like a spacecraft and just descending onto this very cold moon.
And in that case, I would not call them intrepid. I would call them a fucking badass.
Okay, can you guys hear this? I think. Let me know if you don't hear it when it starts.
Okay, yeah.
Oh, wait. You guys won't be able to hear it. Give me 2 seconds.
Click W. Yeah, make sure it's capturing the actual app, not the screen.
I think it is capturing the app. Hopefully.
Is there like music in the beginning title screen here?
No, I haven't pressed play yet.
Okay. Well, I meant like.
Okay, I'm definitively on this screen, so not the.
Okay.
I can hear it.
Okay, I hear stuff.
Wait, you can?
Mm-hmm.
Oh, there it is.
Yeah, very odd noises.
This is my favorite video ever.
These are not the noises that I would have expected.
No, so it's not noises you would actually hear, but someone took all the data coming in And while showing the image that Huygens was gaining, turn a lot of this data into music so you can understand the level of the information it's gathering at one time.
Oh.
Yeah.
Oh, each like tone is like a piece of information. I get it.
Yeah, like that high pitch one is the signal strength to Cassini. You can see it on the right.
Mm-hmm.
And then the others are like spectra coming in, images coming in.
Oh, and I see how in the center, in the core, that there's like some detail there.
Yeah.
Yeah, this is actually what the camera was seeing when it was landing.
Oh, wow.
Yeah, so this is
Oh.
actual video footage of the Huygens probe landing.
Oh, that is very cool. So that isn't like the core of the moon. That's just like the surface.
Yeah, this is the atmosphere right now that you're looking through.
Okay.
And then
very
Which
cool.
is fucking thick. That's
it's
like
really thick.
that's
Like
like
two.
2 C's thick.
And then yeah, what you see here is actually dried up riverbeds, which they
Mhm.
mentioned. And I believe that this was recolored too. Like I'm pretty sure this came in black and white and it's been recolored.
Yeah, that makes sense. There's
Yeah.
no reason to spend resources trying to.
If you look at figure 7.1, you can actually start to see the very like channels that it took that picture of, like here now,
Mm-hmm.
which is really cool. So it's now almost approaching the height of Mount Everest above the surface,
Yeah.
which you can
Wow.
see in the bottom left corner.
Mm-hmm.
Like this is crazy though. This is another moon. This is another surface.
Yeah.
I think what you're getting at there. This is an Earth.
This is an Earth. Like it's fucking nuts.
Come on,
That
fill in
just
the last
like
3 pieces.
this is insane that this is a thing.
If they don't fill in those last 3 pieces, I'm gonna be tilted.
I think the pieces might actually.
Oh.
Oh.
Oh! One more. Come on, you can do it. You can do it. I say to the spacecraft that's long since been decommissioned.
Yeah, I mean, it basically landed, took some pictures, and then died.
Yeah. Mission time. How long is that? 2 hours. It's been descending for 2 hours.
Yeah.
Wait, it's kind of like expanding. Oh, because yeah, that makes sense.
It's a bubble lens.
I was wondering
filled
why the
in.
frisbee was getting bigger, and then it hit me.
Sorry, fisheye lens.
No, it's being expanded. The moon's gonna explode in a second here.
Mm-hmm.
And two, this isn't like active video feed that look like this. Like each of those squares you see are a picture being taken.
Yeah.
So they are doing some artistic licensing here, stretching those
Gotcha.
pictures until we actually get more.
Oh, that noise though. Rip.
So they have the size comparison here of the footprint on the moon compared to the rocks that they're seeing. And these are the pebbles that they were saying are most likely made of water ice.
Very cool.
Oh, that
So
I was
this
going to
isn't
say,
rocks.
like,
This
that's
is
so
ice.
funny.
Are
Because
they like still taking pictures?
Yeah.
it's
and you'll
funny
see
to
the
me
footprint
because
is
it
dying.
looks like they're like river cobbles. They're like so rounded and eroded.
Exactly, because it landed in a dried riverbed.
Yeah.
Yeah. Like there's one of the things. I hope you enjoyed that. I really
Yeah, that was at like
enjoyed
3
that
hours
video.
45 minutes ish.
But where they say over many hours, the Huygens probe parachuted through Titan's atmosphere, collecting images and data as it descended, eventually landing quite softly in a dry riverbed on Titan's surface. This riverbed once carried liquid methane, and the rocks that remain are the tumbled stones of water ice that may have been carried downstream by the seasonal flow of methane. The cobblestones of an alien stream are, quite intriguingly, comparably familiar to rounded ice cubes in a drink left unattended.
Wow.
So freaking cool.
So cool. I thought you guys would enjoy that, so I had to I had to show it. I don't remember. I did remember, but I forgot. 119. Okay. Here we have Rainbow's quote.
I'm putting in another quote actually that I remembered about. Wait, which one?
There's mention that the southern part of Titan was completely dry, while there were lakes in the north, leading to the theory of seasonal lakes. These lakes are truly seasonal. How in the moon could they ever support weird life?
Yeah,
I thought this was interesting because I also briefly thought about this. I assumed some sort of hibernation. Like, I would just assume that whatever weird life exists would have to
hibernation.
Either learn to migrate somehow,
like,
or hunker down until it came back.
Some of the most like energy efficient organisms on Earth are things that live in vernal pools, which is the Earth equivalent of like basically things that dry up, because they have to do nothing for half of the year or whatever. I wouldn't be surprised at all if there was something that could just hunker down and not care.
See, I didn't know about vernal pools. I'll also look into that because that's just something I did not know about.
Vernal pool, like you'll look and you'll be like, oh, I've seen a million of those before, but it's like there's all sorts of salamanders and amphibians that use them as like a integral part of their life cycle.
Oh, yeah.
Like you look at those pictures and you're like, oh, it's a vernal pool, sure. Of course, I know what a vernal pool is.
It's a large puddle.
It's a big puddle that dries up.
Yeah.
And like, it's interesting to me that, like those are a very effective place for things to live. Because it just seems like it would be so complicated to evolve for that. But it also would force you, it's not nearly as complicated as at like a microbial level. Because, you're not really using the whole pool. It just goes from being a little bit wet to a little bit dry.
Look how many frog eggs that is.
Yeah.
Gross. I don't enjoy that. Ew. Yeah, vernal pools. I would imagine, like, if life's weird enough to exist on methane, certainly weird enough to figure out how to exist when the methane goes away for 38 years or whatever it is.
Mm-hmm.
But that would be insane. Some sort of organism that could hibernate or like hunker down for that long.
I mean, cicadas hunker down for what? Is it 17 years on Earth?
Do they really?
Yeah, the cicada. So there's different cicada life cycles. Cicada hibernation period. Yeah, after the long 2 to 17 years.
Jeez.
Wow.
Yeah.
Okay, definitely seems totally plausible then.
Like, I mean, again, 17 to 38 is a huge jump. I don't want to minimize that.
Well, I thought 38 was the entirety. So a season would only be half that.
Yeah.
19 years?
Yeah, 19 years.
Yeah, so 1 Titan year is 29.5 Earth years. So it makes that orbit so half the time.
Mm-hmm.
Which 15 years.
Yeah.
Little under 15 years. So we actually have evidence of things hunkering down longer than that.
And now, you're getting into like how many extreme, evolutionary adaptations can one thing have, but like, if that's what it's got to work with as an environment, sure, why not?
Yeah. Crazy.
Yeah, life is very resilient.
Then on page 117, the whole it says, how thick is the ice and how deep is the ocean? The team that conducted much of this work, led by Luciano Less and colleagues, concluded that the ice shell is at most 100 kilometers thick. I just it's crazy to me because if things did live on the surface, it sounds like they're saying that the entirety of this ice shell lies on the entirety of an ocean.
Yeah, it's a bubble. It's a water bubble. There's no rock in the middle.
It was saying that this ice moved a lot and around a lot, which just like, how do you guys think we would have to adapt to that? Because like, I know we actively live on the ice caps up in the Arctic and Antarctic.
Mhm.
And it's just like interesting to me, like, because we're so used to living on solid ground. Like, do you think it would mimic kind of what it's like living up in the Antarctic or Arctic, where they have to have bases that can move easily because cracking and stuff like that? But also, our ice isn't 100 kilometers thick, so
I mean, at 100
Yeah.
kilometers thick, that's the ground. Sorry, it like, I feel like I feel like you're not going to be able to do much. It would be like it's much more on the scale of an earthquake than it is like ice shifting.
That's kind of what I was thinking, that that much ice would be more solid, if not, just kind of like jiggling a little bit.
Yeah, and if
So I
they
have
say
another
it's moving,
question. If it's always moving, do you think someone who perhaps grew up on that ice shell were to stand on actual solid land would feel like they were moving? Like, do you think they would be able to notice?
I would be surprised if they didn't notice. But on the other hand, like, I don't know.
Yeah,
It would be
I don't
like
know
that
how
thing where,
extreme
like,
movement is.
like they would kind of almost be like their body would be automatically moving, like to kind of
Yeah,
like
it's kind of
on
like
their
when you're on
moving
a
ice.
boat
Yeah, they
and
would
you
have
get
to.
sea legs when you come off.
Mhm.
Yeah,
You're just
exactly.
like, whoa.
Like it's kind of your body being like, okay, I'm moving like this because this ship has been moving like this for hours. But then when
Yeah.
you're on land, you're like, okay, my legs are just moving by themselves for some reason.
Mhm.
Fucking fantastic. Cool. The next thing is a quote on page 119 that I just fucking laughed so hard. The team might have been disappointed that they did not find lightning in Titan's atmosphere, but a global subsurface ocean would truly be a nice consolation prize. Was surely a nice consolation prize.
Yep.
Just like,
Yeah,
fuck off.
very very funny thing for like a scientist to be like, yeah, you know what? We're kind of disappointed we didn't get this.
We'll
On the
take
other
the
hand, there's
ocean.
like an ocean here. There's like an entire ocean here that's like 1,000,000,000,000,000 cubic meters.
Yeah, like, looking for a small discovery finds massive fucking discovery instead. I mean, lightning wouldn't be a small discovery, but proof of a global ocean, when
Yeah.
usually they have to fight for that information, but this time they accidentally came across it looking for something else, like,
Pretty good.
that's funny. I love that.
Mm-hmm.
Also, I feel like you guys didn't ask this one, but fuck you anyways. Until we get back to Titan, we'll never know. And I just wanted to plug the Dragonfly Project again. Y'all should
Oh, I didn't actually see that one.
look up the
I don't know.
Dragonfly Project. I'm gonna look up the Dragonfly Project, spew some information about it. It's super fucking
What
cool.
is the Dragonfly Project?
I'm glad you asked.
The Dragonfly search engine was a part of an internet search engine prototype created by Google.
That sounds right.
Okay.
Yeah, that's it.
We're out of here.
Here you go.
Also, I love that Google is prototyping internet search engines. That seems so off-brand for them.
Okay.
Sorry.
So NASA's Dragonfly will fly around Titan looking for origins and signs of life.
Ooh.
Here, we'll watch a quick little video on it.
Oh, dude, video time?
Okay. Video time. I see a parachute.
This is how the Dragonfly is proposed to land as of now.
Oh, what?
Yeah, it's a quadcopter. Remember that super fucking thick atmosphere? Well, we can
Thicky
fucking
boy.
fly through it. Like a little fucking drone. It is a drone. Just hanging out.
It's like, can they put a
this is
face
an
on it,
animation,
please?
isn't it?
Petition to put a face on Dragonfly.
Like, I feel like that front bit really just is asking for it.
It is.
It does look very creature-like. Like, I know it's called Dragonfly, but
solar powered?
I think it's nuclear powered.
Okay, because I was gonna say I feel like that thicky boy atmosphere is gonna make your whole solar power idea there, bud, a little dubious.
Yeah, so Dragonfly will launch in 2026 and arrive in Titan in 2034. 2034, sorry. The rotocraft will fly to dozens of promising locations on Titan looking for prebiotic chemical processes common on both Titan and Earth. This marks the first time that NASA will fly a multi-rotor vehicle for science on another planet. It has 8 rotors and flies like a large drone.
That's 8
Oh,
rotors.
yeah?
Damn.
Well, I have 9 rotors.
Yeah, they've got rotors on rotors so that when they over rotor a rotor, they can re-rotor it.
That's very true. Very well put.
So its baseline mission is supposed to be 2.7 years, but typically these things get extended, like many of the rovers get extended
Right.
well beyond that they're like when they were expected to end. It will explore the diverse environments from organic dunes to the floor of an impact crater where liquid water and complex organic materials key to life once existed, together for possibly tens of thousands of years.
Ugh.
It will also investigate the moon's atmospheric and surface properties and its subsurface ocean and liquid reservoirs. Additionally, the instruments will search for chemical evidence of past or extant life.
Mhm.
Let's see, what else does it? So, Dragonfly took advantage of 13 years worth of Cassini data, which they talk about here,
Good.
to choose calm weather period to land, along with a safe initial landing site and scientifically interesting targets. It will first land in the equatorial Shangri-La dune fields, which are terrestrially similar to the linear dunes in I thought it was Nambia. I didn't realize that there was an
Namibia?
island for that. Yeah. In southern Africa and offer a diverse sampling location. It will explore this region in short flights, building up a series of longer leapfrog flights up to 5 miles or 8 kilometers, stopping along the way to take samples from compelling areas with diverse geography. It will finally reach the Selk impact crater where there are evidence of past liquid water organics. The complex molecules that contain carbon combined with hydrogen, oxygen, nitrogen, and energy together make up the recipe for life. It will eventually fly more than 108 miles or 175 kilometers, nearly double the distance traveled to date by all the Mars rovers combined.
That's crazy.
Damn.
That's like
Yeah.
that's a lot of ground to cover, and I guess that's the advantage of quadcopters, or I guess octocopters.
Yeah, so Dragonfly was selected as a part of the agency's New Frontiers program, which includes New Horizons missions to Pluto and the Kuiper Belt, Juno to Jupiter, and OSIRIS-REx to the asteroid Bennu. And it's led by principal investigator Elizabeth Turtle, woman plug. Woo!
Elizabeth
Ooh.
She's a
Turtle?
PI. Elizabeth Turtle.
Fuck yeah.
She's
she a
from
turtle?
Johns Hopkins University, the Applied Physics Laboratory in Laurel, Maryland.
Very cool.
Super
Very
cool.
on you.
I'm super excited about this project. It just got accepted like this last spring, so fairly new. But that's all. That was my fuck you. We're gonna talk about what I want for a minute.
No, that's totally cool.
Yeah, I would have exited if I had comprehension, if I had eyes.
Badass. I appreciate that this book was written just long enough ago that things have already changed.
Yeah,
Which is
wasn't
really
it like
exciting.
2008 or something?
Oh, I thought it was way before that. Way after that. Sorry.
Right.
I don't know why I assumed it was in 2008 for some reason.
2020. Like, I literally think it came out the beginning of this year, and then
Really?
Dragonfly got accepted just into this year, if I am correct.
Well, yeah, copyright 2020. How about that?
Duh,
Yep.
thunk it.
Why did I
Hope
think
they
it was
printed
made
on
in
acid-free
2008?
paper. I have no idea. But yeah, so Dragonfly Project. Get excited for that, guys, except for I will personally be 34 when it lands, ideally, if it actually gets there on time.
Yeah.
I'll
Which is
probably be dead.
You might be 36.7 years old.
I could be. Who knows? The next X thing here is chapter 8 from page 129. Let me flip there really quick.
I found exactly one mention of 2008 in the entire book, and it's a picture of Enceladus. That's it. That's it.
That's it. The solid state greenhouse effect is apparently super cool to you, Rainbow. I'm a little mad that the greenhouse effect on
yes.
Earth doesn't result in massive plumes of material being ejected, though.
Yes, I am angry. This is true.
No, you should be happy. Our atmosphere is still relatively thin. I'd like to keep it around.
Like when those holes open up the ozone, it didn't like there wasn't like the Earth didn't leave and like kind of explode through the atmosphere, which makes me very angry to this day.
Well, we still lose a ton of atmosphere sometimes from solar wind.
Mm-hmm.
Solar
Yeah.
wind comes by and will just strip the atmosphere if it actually gets close enough. Especially around the... Oh, fuck, what is that point called? It's the place where the magnetic field, our magnetic field, actually dips lower than the ISS.
The
It's a place of
poles?
high radiation, and like even astronauts are advised to stay away from the windows when they are passing through that
Weird.
area.
I guess the poles would be the strongest points.
No, it's not. It's not a pole. It's over the middle of the ocean somewhere. It's the
Is the Nemo?
No, it's it's unrelated to like anything on the ground as far as I'm aware. I know what you're talking about. I can't think of what they call it though.
Let's see, like what? It's like where radiation can go through.
It's like the weakest point on the magnetic field.
It's not even the weakest. It's because our magnetic field doesn't actually line up perfectly through the center of our planet.
A geometric anomaly.
Yeah, it is.
How pilots cope
The
with
South Atlantic
radiation-
Anomaly. That's what it's called.
The
Perfect.
what?
The South Atlantic Anomaly.
Ooh.
That's what it's called. Here, I'll show you guys. Here is a picture of the South Atlantic Anomaly where the darker it is, the more radiation that's coming through.
Yep.
Ooh.
And so the South Atlantic Anomaly is kind of where the magnetic field is quote unquote thin, but it's not actually thin. It's just
It's offset.
furthest away from where the magnetic field actually exists in the Earth.
That's a lot. That's a large area.
Yeah, it's a big area, biggie boy area. But specifically when they fly over this point here,
Like
astronauts
south
and
of
such
Brazil.
are told to stay away from the windows because it's a place of high radiation.
Hmm.
But atmosphere could also be stripped there a lot easier from winds. Fun.
Wait, what can what?
Fun.
The atmosphere can be stripped away easier there from solar winds because it
right.
magnetizes the particles in the atmosphere and strips them away. But yeah, I don't know a whole lot about the solid state greenhouse effect. I didn't read this with enough time to actually research that.
Oh, the solid state greenhouse effect?
Yeah.
Was this not a discussion?
I mentioned it previously, like when I was talking about cryovolcanism, I briefly mentioned the solid state greenhouse effect as a source of energy for the volcanoes.
Yeah, it just
But yeah,
solid state in that it isn't changing like the one on Earth, right?
solid state referring
Solid
to
state,
the materials that's trapping the heat.
It's solid. The materials are solid.
Yeah.
It's like not greenhouse gases, it's greenhouse solids.
Yeah.
Yeah, it strikes me as sort of the same concept as like having the ice shells that insulate oh my god, brain, go.
Heat?
Nope. I'm trying to think of a name of a moon. Europa. It's like they use the ice shell insulates the inside in a solid state greenhouse effect, right?
I think so. I read past this very quickly.
Uh-huh.
Wait, what was your question?
He's saying that solid state greenhouse would be kind of like the ice shells on the icy moons, keeping it warm.
On the inside, yeah.
I did
It
mention
refracts
this.
that energy back in.
It kind of goes into this other thing I have here about the Clathrates. I hope I'm pronouncing that right.
Mm-hmm.
That they insulate an ocean to the point that very little heating is capable of maintaining an ocean. I actually don't really know where we're going with this.
Oh, I don't. But so I was looking here. Their point of the solid state greenhouse was not heating at all. It's actually why Triton might have plumes.
Okay.
And they're saying dark organic material inside ice absorbs the sunlight and heats up just enough that causes the very unstable ice around it to sublimate and build in pressure until eventually that pressure builds up enough that the ice above it break away and, I quote, an eruption of nitrogen gas and organics occur.
Okay.
So I think what they're just describing here is they were seeing plumes that couldn't be described kind of like the volcanism on Io. They're like, how do we explain this? How do we explain activity on the surface? And their explanation is solid state greenhouse effect.
Sure.
So that's cool. That's neat.
That's neat.
Moving on. I know there's only one last quote here, but I really liked this picture of Triton because they compared it to a cantaloupe. And Triton.
I think I know what a cantaloupe looks like, but I never actually looked it up.
It just like it really does look like a cantaloupe to me. Here's the picture.
Okay, yeah.
Oh, that's very cantalopian. Mm-hmm.
Yeah, like I could. It's also in the book. But I could pick that up and knock on it and like decide it's a good fruit. Like they're so right when they chose like the descriptor cantaloupe. I'm like, yeah, I see that. That's a cantaloupe. And it even has like the rougher bottom that kind of looks like how when melons are on the ground they get those rougher patches.
Mm-hmm. Mm-hmm.
Love it. It's just one big cantaloupe. And now in my mind, for the rest of my life, Triton's just a big fucking cantaloupe. That's all.
Yeah.
Neptune's got a cantaloupe orbiting it.
One thing that I kind of noticed as I was reading through chapter 8 kind of quickly was that it felt like there are a lot of anime characters that I couldn't remember all their names or like what each one was. There was kind of like a bunch of moons with a lot of oceans.
There were definitely a lot of moons mentioned.
Yeah, what was it? Pluto.
I felt like I
Triton,
started to lose
Enceladus.
track.
Yeah, I think there were 4 different moons mentioned and like explained kind of thoroughly alone in chapter 8.
If you go through a list of moons too, their names start getting like less and less like Triton or Enceladus.
Yeah,
it's like
less cool.
Mary. It's Moon Mary, and we're like there's some Shakespearean moons out there.
Oh hell yeah!
It just like really cracks me up. Like, let me see if I can find one of the names of them, and then we'll quickly move on to the last one. Is this Google search going to work?
Maybe.
Okay, we'll just do this. We're going to look at all the moons in the solar system. I'm just going to quickly scroll through them as fast as I can. List of natural satellites. Yeah, so like you have like Phobos and Deimos and like all this other stuff, right? That's like totally normal.
Mm-hmm.
And then you have things like let's see if I can find it. We've got Phoebe. Now we're getting into some really strange names. Kale. There's a moon named Kale. There's so many fucking moons in our solar system. Jesus Christ.
Jesus
Christ.
It's Jason Bourne.
There's Ursa. I'm not finding the ones I'm thinking of. Hold on. There's a moon named Pan. Just Pan. That's it.
Like bread?
Yep.
Or like the god. He was like a nature guy. I don't know.
There's a Carrie.
Oh, the one person who like telekinetically killed all their classmates.
Oh, here we go. Ariel and Miranda.
Miranda?
Yeah, there's Uranus has a moon named Miranda and a moon named Ariel and Umbriel. There's a moon named Bianca. And then of course Juliet, Portia, Rosalind, Belinda, Puck. And then it goes back to like weird names. And it just like it really fucking cracks me up because suddenly there's just Miranda and you're like
very funny.
Okay, cool.
Mm-hmm.
All right, moving
Miranda
on.
doesn't have a global salty ocean.
Get fucked, Miranda.
Yeah.
Miranda's quite small, if I remember.
What wasn't even mentioned in the novel by Kevin Peter Hand, Alien Ocean: Search for Life in the Depths of Space.
I'm so annoyed that I'm gonna have to splice together 3 audio files instead of 2.
Rip you.
Anyways, last one on page 134. Like giant interstellar spaceships, such rogue worlds could potentially transport biospheres across the galaxy. Set up bipedal teams of engineers working hard to keep massive spacecraft on track, these worlds could haphazardly host microbes, fish, squid, and octopi as they unknowingly travel from one star to another. Perhaps one is even on its way to us now. And I remember thinking how crazy it is that we might be Martians. But how crazy is it that we might not even be I don't know, what do you call people from the solar system? What are you going to call people from other solar systems? It's not a system. It's just a system. It's not a solar system. Because, we're Earthlings, and then there's Martians. But what do you Sunshine? Sunshines? Is that what we're called? What do you call someone when they're not from the sun?
Extrasolar? Extraterrestrial? Martians are extraterrestrial, and people from the other side of the galaxy are extraterrestrial, but Martians are not extrasolar?
Yeah. Extragalactic?
Intergalactic planetary.
What
a good song. Have you ever heard that song?
But I'm talking more proper noun, Martian, Earthling.
That's fair, yeah.
What proper noun would people from the sun have? If one of our, say Earth just decided to fucking rocket off to another solar system. What would some other intelligent species decide to call people from the sun, Because at that point, there might be, life from multiple planets in one system.
Mm-hmm.
So you're going to have to generalize them not necessarily by planet, but by system.
Yeah.
And I don't think anyone's considered this before, and I've considered it now. Yeah, fuck you. Well, Sol is inherently sun. Sol means sun. So it wouldn't be a solar system. We're the only solar system. Technically, right? Solar is a proper. I thought, but sol in Spanish means sun.
Interesting here.
And there's another word for stars in Spanish. So, but I'm also basing this off of Elite Dangerous. Not gonna lie.
Is there a lowercase solar system, or is there only the solar system?
I don't know. Are you gonna look up?
I'm looking at it. Because Wikipedia pulls up the solar system, which makes me think that that's the proper noun name of where we're from.
Well, it is I thought so because in my astronomy classes we call them other star systems. We don't call it the solar system.
Yeah, but I wonder if that's just for clarity.
System. Huh?
What happens if we define solar?
And then on top of that, if it's around a star that we know, it's typically that star system. So the Andromeda is not a star, but it'd be the Andromeda system.
Yeah, it's definitely giving me solar system is capitalized. I can't find an instance where it is extra, a different solar system.
Right. So that's proper noun, Martian proper noun, Earthling proper noun. What we call people from solar system, the solar system.
So that's so fucking pretentious. Oh yeah, where are you from? Oh, I'm from the solar system. That's fucking obnoxious.
But also, even if you were from, the Betelgeuse system, you would say the Betelgeuse system.
Right, but for some reason in my mind, I guess this word the term solar system is so general. Even though we have just looked it up and it's definitely a proper noun, in my mind it's still oh, but you can. Interesting. They're giving me the option of a plural as well for solar systems.
Wait, what?
Yeah.
I'm just gonna go off what we call it in astronomy, which would be
mm-hmm.
not other solar systems
other star systems is what we typically call them. And in my astronomy classes, solar system is capitalized in a proper noun.
Yeah, it's interesting because on Google's dictionary it gives me solar system is the collection of 8 planets and their moons in orbit of the sun. But it also gives me the opportunity to make it plural, which seems kind of obnoxious when it's such a singular idea.
I think perhaps we have found a
glitch
break in the English system.
Yeah.
A glitch. But like Solarians, maybe?
Solarians, almost certainly.
Solarians? I like Solarians.
Yeah, I'll be a Solarian.
I'm a Solarian. Let's go. We're not Earthlings or Martians. We're Solarians. Stand united. Ha!
I'm not really a nationalist. I'm much more of a Solarist.
I'm a Solarist.
And the dumb thing is you'd say that and be like, oh, cool, I'm an Aries. And you'd be like, shut the fuck up.
Well, I can tell you with 100% certainty, the sun is a proper noun, kind of like saying the moon is a proper noun. And you never say a sun. Like, never once ever in any of my astrophysics classes have we called another star a sun. We call it its star, or that star, or their star. It's never... Like, the sun is our sun. It's the sun. It's the only one. It's ours.
Da sun.
Da sun. The one that specifically concerns us. So. Yeah. Like, if you put the in front of it, moon becomes proper. Whereas you can use the word moons to mean just like satellites.
Yeah.
That orbit a body, which is oftentimes what they are also called in astrophysics. It's just like a planetary satellite, or a rocky satellite. But it is kind of interesting that we will use moon to describe other things, but I can definitively say you do not use suns, or it has many suns, or this sun is red. It's because our sun is not red. It is just sun.
Yeah.
Yeah. Yeah. Also, I really like the idea of just like a planet flying through our solar system and we're like, holy fuck. And we go land something on it or stop it somehow and there's just like fucking octopi on it. Just like, hey man, what's up? And we'll just be like, oh shit. Like, okay.
Yeah, what was it that came through? We had the first like truly extrasolar object fly through the solar system like last year.
Yeah.
What was it called?
I don't remember.
Oh god. Now I can't remember.
I'll look it up. And then we should probably call it.
Well, this was the first asteroid we've ever been able to verify was from outside of our solar system, not just something that got knocked in off the Kuiper Belt or the asteroid belt.
So it was likely from another one. It was just C2019. Oh no, that's right. It was called Aumama. It's a Hawaiian word.
Yeah, that's why I couldn't remember it. Pull it up.
Oumua. I didn't do it on my computer.
Yeah. I remember it being a super big deal.
Yeah. Oumua.
Yeah.
It's pronounced Oumuamua. Wait. Oumuamua. Oumuamua. Yeah.
Something to that effect. The first known interstellar object passing through the solar system.
Yeah, it was first discovered in 2017. And then I think it came closest last year?
Well, it actually did it went through the solar system. I feel like it was recently. Oh no.
Was it in? No, it was just in 2017. Wow, God. I don't know.
Time flies when you're having fun.
It left our solar system last year.
There was
In
some
2019 of January, it traveled beyond Saturn's orbit.
Yeah.
And it's heading for Pegasus now, the constellation Pegasus.
Yeah, and there was something about it making a very odd turn.
No, it didn't make a super odd turn, but its shape is very strange. It's long. It's very long and sharp.
Yeah. Yeah, that was like, that was one of the theories, was that it was, extrasolar and it was moving in an odd way. Like I think if you look at the animation that's available on the Wikipedia page, it certainly doesn't see here. Yeah, so non-gravitational acceleration. Yeah. Astronomers reported a non-gravitational acceleration to Oumuamoo's trajectory, potentially consistent with a push from solar radiation pressure. Internal speculation as cause of this acceleration pointed to comet off-gassing, whereby portions of the object are ejected as the sun heats the surface, although no such tail or gases was ever observed following the object. So people were like, Armageddon, it's an alien, which is sick. And then they were also noting that...
And it wasn't just they didn't see outgassing, there was no outgassing.
There was no outgassing, and that it would normally have caused like an object of that shape to spin. Yeah. Mm-hmm.
Yeah. They also just talk about like the fact that we even did see it.
Yeah.
Like what the fuck? How the fuck did we see it? Which is also why it was super important, because they probably go through our solar system on the regular.
Yeah, it's just what are the chances that we're looking in the right direction?
Yeah.
Mm-hmm.
All right, well, I think that's it for this year. This week.
See y'all next year, folks.
See y'all next year. I think that's it for this week. I'm fucking hungry. I'm gonna get dinner.
Mm-hmm.
We do love to hear it. Yeah, so next week we will be reading week 4 all the way through chapter 11. Which is, let me find it here. We'll be reading chapter 9, Becoming Inhabited. This is beginning part 3, The Journey from Habitable to Inhabited.
Mm-hmm.
Chapter 9, Becoming Inhabited. Chapter 10, Origins in an Alien Ocean. And chapter 11, Building an Ocean World Biosphere. So, got that to look forward to. I will make the Google Doc, probably not today, because I know I'm going to get distracted eating food. Remind me to do it tomorrow or whenever you guys actually end up wanting it. And let's try to not read it last minute last time.
Yeah, let's do that. Go team.
Yeah, we got that hour and a half in just fine. I was watching it.
Dense.
Yeah. I was a little okay with the tangents this time just because normally we fill up 3 pages and we didn't even really fill up 2 this time. So
yeah, I apologize. That was partially me. I was listening while doing something else and not taking notes.
No worries. How dare you sit there and fuck with your dishwasher? Unbelievable.
It's the worst. I didn't even fix it is the dumb part. Like, it's not better yet.
oof. Well, that is stuff.
Yeah, no. Nope. Yeah, just like that. Uh-huh.
I can't get him to leave.
Goodbye.